After extensive testing and careful consideration, the United States has committed billions of dollars to upgrade its fleet with new helicopters designed to replace the iconic Blackhawk. This decision reflects a drive to enhance aircraft technology and boost the effectiveness of military operations. So, which new helicopters have been selected for this upgrade, and how do they differ from the original Blackhawk model? In this video, we'll explore the details of the newly chosen aircraft and the advancements they bring compared to the legendary Blackhawk. The Blackhawk helicopter. During World War II, helicopters first made their debut in combat roles, initially used for search and rescue, as well as medical evacuations. Over time, their applications expanded to include offensive operations. Stephen Thomas, in his book Blackhawk, notes that the true evolution of helicopters for tactical warfare began with the introduction of the Bell UH-1 Iroquois during the Vietnam War. Lieutenant Colonel Hammer is credited with pioneering the strategy of deploying troops into combat zones via helicopters, and then quickly extracting them after engagements. The success of this approach led the U.S. Army to seek a more advanced helicopter model. The goal was to create a helicopter that was not only capable of transporting troops, but also more powerful, quieter, and more agile than the UH-1. In response to these requirements, the Army launched the Utility Tactical Transport Aircraft System program in 1972 to develop a new generation of transport helicopters. By 1976, Sikorsky won the contract to produce the UH-60, marking a significant advancement in helicopter technology and its role in modern warfare. Army helicopters are typically named after Native American tribes, and the UH-60 was designated the Blackhawk. It first entered combat during the 1983 U.S. invasion of Grenada. Since then, the Blackhawk has racked up over 5 million flight hours, playing crucial roles in operations across Panama, Southwest Asia, Iraq, Afghanistan, Somalia, and Bosnia. In 1989, the Blackhawk received a significant upgrade with a new power plant. The helicopter achieves lift through its engines, which rapidly spin the rotor blades, creating differential air pressure. As the blades turn, they move air faster above them than below, generating lift once the pressure below surpasses that above the blades. The Blackhawk is powered by two General Electric T700 GE 701C turboshaft engines. These engines drive a shaft that extends to the rotor head, which consists of a rotor hub and 4 blades. Each blade is constructed with a titanium spar, a metal strip running from the blade's base to its tip, and a Nomex honeycomb core. The blade's skin and trailing edge are reinforced with composite materials for durability. The rotor disc spans 53 feet 8 inches in diameter, necessary for larger helicopters like the Blackhawk that carry significant loads. The leading edges of the blades are made of titanium and nickel to withstand the stresses of flight. As the drive shaft rotates the rotor head, the spinning blades generate a powerful rotor disc, capable of lifting the helicopter along with its crew and up to a 9,000-pound external payload. The Blackhawk's attributes and maneuverability. The Blackhawk's tail rotor, with its 11-foot blade, plays a crucial role in stabilizing the helicopter by creating a lateral force. This tail rotor also allows the pilot to steer the helicopter left or right by adjusting its pitch. The helicopter's impressive power and maneuverability enable rapid deployment of soldiers to key locations on the battlefield and their swift return to safety. To enhance lift, the pilot can adjust the swash plate assembly, which manages the torque generated by the blade rotation. This torque would cause the helicopter's fuselage to spin in the opposite direction if not properly countered. The Blackhawk is not only used for transporting soldiers, but also for carrying artillery and other essential equipment. It features built-in safety systems designed to protect the crew and soldiers in case of an attack, which is vital during military operations. Its ability to move large numbers of personnel and equipment to areas inaccessible by ground vehicles makes it indispensable for combat support and logistical missions. Designed with flexibility in mind, the Blackhawk can be reconfigured to suit various mission needs. It requires a 3-person crew, 2 pilots, and 1 crew member. The helicopter can carry up to 11 fully equipped soldiers, along with substantial amounts of supplies and weaponry to remote locations quickly. Its interior, equipped with various tie-downs, can be rearranged to accommodate different types of missions. The Blackhawk can carry additional external cargo thanks to its External Storage Support System, ESSS. This system features detachable stub wings mounted on either side of the fuselage above the cabin. Each of these wings includes pylons capable of supporting up to 9,000 pounds of external cargo. This includes items such as fuel tanks, electronic countermeasure modules, 16 anti-armor Hellfire missiles, firearms, and mine dispensers. Additionally, the Blackhawk is equipped with a cargo hook on its undercarriage, allowing it to transport large objects like small vehicles, artillery, and substantial supplies. For navigation and situational awareness, the Blackhawk is fitted with a VOR marker and an automated direction finder. The Army variants of the Blackhawk can be customized with stub wings for extra fuel tanks or weapons, depending on the mission's requirements. Among these variants, the UH-60L Blackhawk, produced from 1989 to 2007, features enhanced durability with a more robust gearbox, an upgraded flight control system, and improved engines. Moreover, newer UH-60Ls are being equipped with the MH-60K's GE701D engines. The first Blackhawks were ordered by the 160th Special Operations Aviation Regiment of the U.S. Army in 1988. The Blackhawk used for defense. Although the Blackhawk is not designed as an assault helicopter like the Apache, it still needs to be equipped with defensive weapons to protect its crew and passengers both in the air and on the ground. The Blackhawk is outfitted with various built-in defensive systems and artillery to safeguard its occupants. Given its role in combat, it is a prime target for enemy fire, including small and medium-caliber weapons, so it is designed to withstand such attacks. The helicopter's airframe is constructed from metal, with other components like the floors, doors, and fairings made from composite materials. Fairings are strategically placed between joints to streamline the helicopter, enhancing speed and maneuverability while minimizing damage from enemy fire. The Blackhawk is resistant to most medium-caliber high-explosive missiles and small arms fire. It also features ballistic-hardened flight controls and a crash-resistant self-sealing fuel system to mitigate damage from impacts. For added protection during emergencies or hard landings, the Blackhawk is equipped with armored seats and swing-out side panels. The energy-absorbing landing gear and chairs help safeguard passengers, allowing the helicopter to endure vertical impacts of up to 38 feet per second. The fuel cells are also designed to withstand drops from up to 20 meters. In the event of a tail rotor failure, the fin attached to the tail can be adjusted to maintain control of the helicopter. After a crash, pilots have the option to escape by pushing aside the cockpit doors and using the emergency pop-out windows. The Blackhawk must be prepared to withstand both rocket and bullet fire, while also having sufficient armament for the crew to defend themselves. Typically, 2 gunners are stationed within the helicopter to operate 7.62mm machine guns mounted at the cabin windows. These guns enable the crew to return fire and provide protection for soldiers as they board or disembark during combat situations. When equipped for offensive operations, the Blackhawk can carry Hellfire missiles, though medevac variants generally do not have these missiles on board. Instead, medevac helicopters are used for transporting injured personnel along with necessary medical supplies. Additionally, the External Storage Support System, ESSS, allows for further armament options. The Blackhawk can be outfitted with a 30mm chain gun or a 20mm gun pod, depending on the mission's requirements, replacing the Blackhawk. After decades of service, the U.S. Army has decided it's time to replace the Blackhawk with a new aircraft. The Army has committed over $1 billion to develop a new model that will eventually replace around 2,000 Blackhawks. The competition is between 2 main contenders, Bell's V28 Valor and the Sikorsky-Boeing SB1 Defiant X. The decision process has been extended as the Army reviews these bids. Bell's V28 Valor and the SB1 Defiant X, developed through a partnership between Sikorsky and Boeing, represent the next generation of versatile helicopters designed to succeed the Blackhawk. The Army has indicated that a decision will be announced by the end of the year. The SB1 Defiant X is envisioned as a highly adaptable helicopter, part of the future of aviation technology, alongside other innovative models like the AH-64 Apache, another Sikorsky product. Modern helicopters such as the Bell V-22 Osprey, with its distinctive design, also capture the imagination, highlighting the evolving landscape of military aviation. The SB1 Defiant. As part of the Future Vertical Lift military program, the United States is developing 5 new helicopters, each designed with advanced sensors, avionics, engines, and armament to transform combat capabilities. One standout among these is the SB1 Defiant, a high-speed, multi-purpose helicopter designed to be the most agile, fastest, and resilient attack helicopter ever built. By 2035, the Defiant is expected to excel in navigating challenging terrains, delivering troops and cargo efficiently, and swiftly exiting dangerous areas with minimal risk. The SB1 Defiant and the Bell V28 Valor were chosen as demonstration models during the 2014 Future Vertical Lift program development phase. Since then, their creators have been refining these advanced designs. The Defiance prototype was unveiled by Boeing and Sikorsky in 2018, with ground testing beginning in January 2019, and its inaugural flight occurring in late March 2019 at Sikorsky's facility in West Palm Beach, Florida. The Defiant promises significant improvements over the Blackhawk, which has been a reliable combat helicopter for 40 years. Its advanced features and enhanced performance are poised to set a new standard in military aviation. Difference between Blackhawk and SB1 Defiant. During testing, the SB1 Defiant prototype demonstrated impressive performance, reaching speeds close to 230 miles per hour, compared to the Blackhawk's top speed of 183 miles per hour. Engineers are aiming to push the Defiant's speed even further, with plans to achieve up to 290 miles per hour. This enhanced speed is achieved through the use of coaxial rotors that spin in opposite directions and an additional push propeller, a departure from the UH-60 Blackhawk's traditional 5-blade main and tail rotors. The coaxial rotors provide a 115 mph speed boost, extend the combat radius by 60 miles, and improve hovering capability at high altitudes and temperatures by 50 mph. Another significant upgrade is the SB1 Defiant's larger cockpit, which has increased by 50% compared to the Blackhawk. This expansion allows for greater operational flexibility. The SB1 Defiant can accommodate up to 12 armed soldiers and a crew of 4, including a commander, co-pilot, and 2 mechanics. For medical evacuations, it can be reconfigured to transport 8 wounded soldiers and 2 medics, whereas the Blackhawk can carry up to 6 stretchered casualties. The Defiant's opposing rotors contribute to increased lift, stability, and smooth operation, while the pusher propeller offers significant forward thrust during flight. Test pilots liken the experience of flying the Defiant with the pusher propeller to the sensation of taking off in a high-speed aircraft, akin to a car turbine. This innovative design provides the Defiant with notable advantages in vertical takeoff and landing capabilities, setting it apart from its predecessor, the UH-60 Blackhawk. Maneuverability of the SB1 Defiant. The SB1 Defiant offers exceptional agility compared to standard helicopters. Unlike traditional models, which require a significant reduction in speed to perform sharp turns, the Defiant can maneuver sharply even at full throttle. This capability provides pilots with a tactical advantage, allowing them to quickly adjust their flight path during combat. The military anticipates that the Defiant will excel in future urban battles, navigating between skyscrapers with ease due to its advanced maneuverability. Weighing around 30,000 pounds, the Defiant benefits from its vertical takeoff system, which allows it to hover and maneuver with remarkable lightness, a significant improvement over the UH-60 Blackhawk. The Blackhawk, by contrast, has a more conventional approach where its blades continue to spin while on the ground. The Army envisions helicopters operating at high speeds and low altitudes to evade enemy ground vehicles. The SB1 Defiant excels in this role, able to slow down from speeds of up to 230 mph to a hover just half a mile from its target. This rapid deceleration capability has been well regarded by test pilots, who highlight the Defiant's ability to maintain visibility of the landing zone, enhancing both operational effectiveness and crew safety. In contrast, the Blackhawk's approach required tilting the nose up 30 degrees during similar maneuvers, obstructing the pilot's view of the landing area. To achieve quieter operation compared to the UH-60 Blackhawk and other traditional helicopters, the SB1 Defiant incorporates the latest anti-vibration technology. This innovation includes 4 generators that emit vibrations at a frequency opposite to that of the rotor blades, similar to modern noise-canceling headphones. This design minimizes external noise, allowing pilots to focus better on their surroundings. While engineers ensured that the Defiant's speed and maneuverability were not compromised by heavy armor, they also devised a safety feature to enhance its operational security. If needed, the SB1 can be modified to operate without its pusher propeller. In this configuration, the Defiant would function as a standard twin-engine helicopter, still capable of hovering and flying at speeds of up to 172 miles per hour, even if it loses one engine. Although some experts have expressed concerns that this modification might reduce the helicopter's overall survivability compared to the Blackhawk, the Army maintains that the SB1's design allows for effective evacuation and operational flexibility under threat. In critical situations, the SB1 remains capable of rapid flight and hovering, ensuring that it can continue to safely extract troops even if it faces significant challenges. The Bell V28 Valor. The Bell V28 Valor stands out as a top contender for meeting U.S. Army requirements due to its impressive balance of cost and performance. Its design leverages a modular open systems architecture, utilizing Internet Protocol interfaces and data standards. This approach facilitates rapid, low-risk updates and maintenance improvements, ensuring the helicopter remains adaptable and future-proof amid evolving technology, particularly in computing, artificial intelligence, and advanced sensors. The V28 Valor significantly enhances performance compared to current fleet helicopters. It offers more than double the range and speed of the Blackhawk, combining the speed and efficiency of a turboprop with superior agility. This makes it an ideal long-range assault aircraft capable of supporting ground forces with the necessary speed and maneuverability for multi-domain operations. The V28 Valor operates with a cruising speed of 280 knots, aligning with its name, and can achieve long-range cruise speeds exceeding 300 knots. With a combat range of 500 to 800 nautical miles and the ability to cover up to 2,100 nautical miles, it excels in both military and humanitarian missions. The helicopter has accumulated 215 flight hours over 3 years, showcasing its reliability and performance. Its enhanced range and speed provide exceptional mission flexibility, enabling rapid responses to global issues and faster delivery of medical care to improve survival rates in combat situations. The Bell V28 Valor boasts advanced triple-redundant fly-by-wire technology, providing a significant advantage over traditional rotary systems. This technology has shown remarkable performance in low-speed domains and flight tests, offering superior Level 1 attitude responsiveness. This capability allows the V28 to perform agile maneuvers, such as rapid lateral displacements, while maintaining optimal energy levels. The tilt-rotor design of the V28 Valor enables it to execute swift and dynamic movements, akin to those of fixed-wing aircraft. Unlike conventional helicopters, which face challenges with rotor disc separation and main rotor issues, the V28's tilt-rotor system eliminates these concerns, allowing for high-speed operations without overloading its dynamic systems. The Valor's wing platform, coupled with its tilt rotors, facilitates sharp, high-speed maneuvers, maximizing the helicopter's agility. This design minimizes mass limitations associated with rapid maneuvering and ensures effective performance in various flight conditions. Difference between Bell, V28, Valor, and Blackhawk. The Bell V28 Valor draws inspiration from the UH-60 Blackhawk, incorporating several design improvements to enhance performance and safety. Although the V28 has a slightly larger footprint than the Blackhawk, it is more compact overall, being about 20% shorter. This reduction in size is due to the absence of exposed rotors at the leading and trailing edges, contributing to increased safety in landing zones. This design eliminates the need for complex propeller engagement mechanisms and routine rotor tilting, simplifying operations both inside and outside the aircraft. The V28's fuselage shares similarities with the Blackhawk but features distinct enhancements. It is powered by the General Electric T64 free-turbine turboshaft engine, differing from the engines used in the earlier Bell V22 Osprey. The V28's engines are designed to remain static, while the rotors and drive shafts tilt, providing a consistent power output. In the event of an engine failure, a drive shaft integrated into the straight wing allows both prop rotors to be powered by a single engine, ensuring continued operation. Additional features of the V28 include a V-tail design, a triple-redundant fly-by-wire control system, and flexible landing gear. The wings are constructed from a single piece of carbon fiber reinforced polymer composite, which reduces both production costs and the overall weight of the helicopter. The Bell V28 Valor features a longer wing and lower disc loading, which enhance both its hover and cruise efficiency compared to the V22 Osprey. The Osprey's higher disc loading results in less effective hover performance compared to conventional helicopters. The V28 can carry up to 14 soldiers and accommodate a 4-person crew with its 2 cargo hooks. It is capable of transporting a 10,000-pound howitzer while achieving speeds of up to 150 knots. Inside the V28, the cabin includes windows that display a 3-dimensional mission map. Additionally, seats are equipped with wireless charging capabilities for devices such as radios, night vision goggles, and other essential electronics. Although currently designed primarily for utility missions, Bell is also developing an assault configuration for the V28. This flexibility allows a single airframe to switch between different payloads and mission types, potentially enabling the V28 to perform both utility and attack roles. Bell envisions the Valor's tilt-rotor platform as adaptable for a range of military operations. Replacing the Blackhawk with the Bell V28. The choice between the SB1 Defiant and the Bell V28 Valor has been a focal point for the U.S. Army as it considers a major upgrade from the decades-old UH-60 Blackhawk helicopters. After extensive testing and evaluation, the Army decided to replace its fleet of 2,000 Blackhawks and 1,200 Apache helicopters with the Bell V28 Valor tiltrotor aircraft. The Bell V28 outperformed the Sikorsky-Boeing SB1 Defiance, earning it the contract under the Future Long-Range Assault Aircraft (FLRAA) program. The development contract awarded for the V28 Valor is substantial, with a total ceiling of $1.3 billion, making it the largest procurement by the Army in over 30 years. This significant decision underscores the Army's commitment to modernizing its aviation assets. The Bell V28 Valor was favored largely due to its successful development and testing as part of the Joint Multi-Role Technology Demonstrator (JMRTD) initiative, which began in 2013. Years of rigorous flight tests have provided extensive data highlighting the aircraft's advantages for long-range operations. The V28 has demonstrated notable progress in design and performance, particularly during flight tests. Scott C. Donnelly, chairman and CEO of Textron, expressed pride and appreciation for the Army's selection of the V28 Valor as the future backbone of its attack aviation. Mitch Snyder, the president and CEO of Bell, expressed his excitement and honor at the opportunity to collaborate with Army aviation. He is committed to developing an exceptional weapon system that meets the Army's rigorous mission requirements. Bell's long-standing support for Army aviation is evident, and Snyder is eager to contribute to the delivery of a highly reliable long-range assault aircraft. He views this as a pivotal moment for both Bell and the U.S. Army as they work together to enhance Army aviation capabilities for the future. Bell has rigorously validated the V28 Valor aircraft and is preparing to integrate it into the Army's modular open system. Snyder reiterated his readiness to support the Army with a top-tier long-range assault weapon system. Keith Flail, Bell's Executive Vice President of Advanced Vertical Lift Systems, highlighted the V28 Valor's improved platform affordability and the team's demonstrated operational capabilities over recent years. General Robert Barry, the Executive Program Officer for Aviation, announced that Bell's initial $232 million investment will fund the preliminary design and development of a virtual prototype. This prototype will assist the Army in advancing its acquisition process, with the acquisition phase expected to span the next 19 months. No aircraft will be procured during this initial phase. There are currently two prominent approaches in the competition for the Army's next-generation aircraft. One led by Bell Textron with its tilt-rotor design, similar to the V-22 Osprey used by the Marines. When asked about what sets the tilt-rotor apart from its competitors, General Robert Barry did not point to any single factor. Instead, he explained that the decision was based on a comprehensive evaluation of performance, cost, and schedule, with all these elements carefully weighed in the decision-making process. Barry highlighted that the Army's initial order for low-rate production is valued at $7.1 billion, covering the engineering, manufacturing, and development phases of the FLRAA contract. Additionally, there is a potential for the contract to reach up to $70 billion, depending on the quantity of aircraft purchased over time, which may also include foreign military sales. According to Keith Flail, Bell's Executive Vice President of Advanced Vertical Lift Systems, the V28 Valor is set to deliver a cutting-edge rotorcraft for the U.S. Army. This tilt-rotor aircraft combines the attributes of both helicopters and traditional fixed-wing aircraft. It surpasses the Blackhawks in key areas such as speed, sling load capacity, and tactical capabilities, including the ability to hover while allowing troops to board or disembark. Carl Hoffman, Bell's Vice President of Future Vertical Lift Strategy, emphasized that the V28 Valor represents an evolution of tilt-rotor technology, tailored specifically for the Army's air assault and utility missions in challenging environments. He assured that the design is reliable and field-maintainable, with every component capable of being serviced using standard ground support equipment in austere conditions. The initial prototype of the V28 Valor is expected to be delivered to the U.S. Army by 2025. The specific performance criteria that the Valor must meet before it enters service are classified and not publicly disclosed. Thanks for watching. We'll see you in the next video.